All right, so we're going to go over section 2, 3, and 2, 4, graphing and writing equations of lines, which is a nice little review, and then we'll touch base on some important things that we hope you remember. So the first thing, obviously the number 1 says we need to use our graphing calculator to sketch and compare graphs and make conclusions along the way. So I'm just going to use Desmos here. I have these graphs pre-written, so I'm just going to pull them up as we do that. So for the first one, we look at this line, 3x plus 5, and we see this one. So the most important thing that we should conclude right away is we see that they are parallel lines. And what's important about parallel lines, which is the symbol, remember we can use that, is they have the same slope. But then we also make some sort of qualifier, they're not the same line though, so we normally say different y-intercept or something, because we want to make sure they're not the same exact line. And then other things we'd ask you to notice right now is when we sketch this here, we can see that this is 0, 5. Because that's the y-intercept, the up 5. And then this one's not in y-intercept form, but what we can see is it has some ordered pairs here and stuff like that. So we're just kind of noticing the shifts of the y-intercept form, a little harder to see because this isn't a specific form of a line. So you could say notice y equals mx plus b, right? And then this was the shift up, because it's not grouped with x. So let's look at the next two. And again, I already have them loaded in. So here's the first one, and here's the second one. Maybe. So what's really important to notice about these is they're not parallel, they are perpendicular to each other. So we'll just kind of draw that as best as we can. And to indicate they're perpendicular, it's okay to put a little right angle in there. So these are perpendicular lines. And again, that's the symbol for perpendicular if you were unfamiliar. And then from there, why they're perpendicular, I just recall that they're the opposite reciprocal slopes. So opposite reciprocal, so the opposite means the opposite sign, so negative to positive, and reciprocal means flip it over. So instead of 5 being on the bottom, it'd be on top. Kind of the important things that we'd want you to look at for that one. Looking at the next one, I already see that they have the same slope. But this is our example, so there's the first line in black, and I'm going to put on the second line, but you're not going to notice anything because they're just right on top of each other. You can kind of see it coming in and out. So when we draw these, again, we can kind of notice that shift from before, the plus 6. But there's 2 of them on top of each other, so this is the same line. And again, kind of just contrasting what we did for the parallel lines, we know that they're the same. They have the same slope and y-intercept. And that'll be good enough for us to have the same line for right now. Again, it's kind of hard to see because this isn't a true form of the line, and they're not written in the exact same equation, but if we simplified it, if we distributed, so 24 by 3 is 8 minus 2. So we would eventually see that the equation could be modeled in the same way. And then the last one, just super important for us to see vertical versus horizontal lines. So what we want to see, just to make sure that we're clear, the x equals some sort of number is a vertical line. And just recall, the equation of a line means that the ordered pairs on that line satisfy this relationship. So if I plugged in 0, 6, the y value would be equal to 2/3 of x plus 6. So no matter what point I choose, it makes that true. So with a vertical line, we just remember that all these things here have the same x value. So in this case, our x value is 7. And I'm not going to label the y values because I don't really care about the scale on them, but this is always just going to equal a number. And if you can't remember if it's horizontal or vertical, if I give you the rule for x, every point on this line needs to satisfy that rule. So then y, obviously equaling just a regular number, is our horizontal line. And it's really for the same reason. So at negative 6, if I plot some points 0, negative 6, or whatever this x value is, it has the y value of negative 6. So the rule is all the y values are negative 6. And just recall x is perpendicular to y, right? Or vertical lines are perpendicular to horizontal lines. So then just moving forward, we just want to remember the different forms of a line that there are. So slope-intercept form, y equals mx plus b. Point slope form, y minus y1 equals m times x minus x1. Standard form, traditionally a capital AX plus BY is equal to C, and we just did the horizontal and the vertical lines, but Y equals a number and X equals a number. So then when you're using those equations to graph, like the most important thing about a line, like place a point and then use the slope to get more. So like on this one, I observe what form it is, and it's in y-intercept form or sloped-intercept form, which means this is the y-intercept. So I'm going to place that point first. And I'm going to use the slope of down 2 and over 5 to place more, or up 2 and left 5. But again, I just have to make sure that I get a negative sloped line, but I use the slope to plot more points. And then there's a quick little sketch of our line. I'll move on to the next one. What we see here is that this is point slope form. So if it's in point slope form, the biggest thing here is kind of remembering that it has to be in a certain form. This needs to be written as a minus in order for us to see the point. So if you need to see a minus and -8. But this is our x value, the number that's being subtracted. So the point we have has an x value of 1. The number that's being subtracted here is -8. So the y value is -8. So that's the point that we're going to place. And then just like we did before, as we see from our form, m, the slope is right in front of the parentheses. So if I can't go down 5, right 2, I'm going to go up 2, left 5, or up 5, left 2. So 1, 2, oops. And then 1, 2, 3, 4. 1, 2. Place another dot. Place another dot. Now it's best to fill as many dots as you possibly fit on the graph. And again, that should be a downward sloped line because of the negative slope. So when it comes to standard form, so we have question 4 about standard form and question 5 about standard form. There's 2 different ways that we can graph standard form, just as a reminder. One of the most common ways is just to convert it to slope-intercept form. Recall that just means get y alone. So like with this one, it doesn't really matter the order that we do it. I'm going to subtract 4x from both sides. So I have -3y is equal to 12 minus 4x. I'm going to divide everything here by 3. And I'll just rearrange real fast too. I'll put that 4/3 x first. 12 divided by 3 is a +4. And then it turns into what we were just doing before. If this is a line, I have to plot a point first. So we'll plot the y-intercept first because that's the point given in this form. And then we'll use our negative slope to make sure that we can plot some more points. So 1, 2, 3, 4, 1, 2, 3. And again, just make sure that your line is negative. So you know that the slope of a line, the top is either up and down and the bottom is always left or right. It doesn't matter what direction you go, up or down, as long as your left and right will make a negative slope line. So if I go up 4, I'd have to go to the left 3 to make sure that my line slopes negatively. And just another example here, if I wanted to get y alone, we'd subtract 7x's from both sides. So 5y would equal -7x, and then there was also a -35. And again, you can see that we're just dividing by 5. So we can see our slope is -7/5, and our y-intercept is -7. So we place that. I can't go down 7, so I'm going to go up 7 and over 5. Up 7, over 5. So